Now let us solve this problem. These are simultaneous differential equations of first order. So, given the initial condition x 0 as 1 and x y 0 as 0. Okay. Now let us solve by different methods. So let us see one of that method. Okay. Now uh, these are the equations. So I can write this as dx, d by dt as d. So dx minus dy as e to the power of t, and dy plus x is sine t. Now uh, let us eliminate any one of the function, either x or y. So if you would like to eliminate y, so that I can multiply d to the first equation. So this will be d square x, and that's cancelled. So d square x plus x is equal to e to the power of t plus sine t. Now this is your differential equation, which is non-homogeneous. Okay, if we rewrite in this form, okay, power of t and sine t. Okay, which is the form of f of d into x is this is some function, okay, which is r of x. Okay, this is second order differential equation. Now let us solve this. We get x, then find y. Okay, so let us first find the complementary function. Okay, so f of d of x is into x is 0. So this is d square plus 1 is equal to 0, which is uh, auxiliary equation. We get as m square plus 1 is equal to 0, or xc is, these are the roots, plus or minus I. So xc will be c1 cos t plus c2 sin t. Okay. Now we got to find the particular integral, that is xp, which is e to the power of t divided by d square plus 1 plus sin t by d square plus 1. Okay, so we'll put this as p1 and this is p2, particular integral 1 and 2. So for p1 will be that is when you substitute d as a, okay, so that is e to the power of t by 2. Now p2 will be, now when you substitute d square as minus a square, which is 1 square, so this becomes 0. So that is a sine t by 0. So again you have to find for once you get the denominator 0. So that is t multiplied sine t, and differentiation of this function, which is f of d, which is d square plus 1, f dash will be 2d, or uh, this is minus 1 by 2 uh, t cos t. Okay. So we got p1 and p2. So xp will be, and I will combine xp and xc. So by putting this together, so x is equal to xc plus xp. So x is c1, xc is c1 cos t plus c2 sin t, and xp we just got it as e to the power of t by 2 minus t cos t by 2. Okay, now let us find x dash. This is x of t, right? X dash of t will be uh, minus c1 sin t plus c2 cos t, and this is half e to the power of t, and this is minus half cos t plus half t sin t. Okay. Now, when you substitute t as 0 for this, so we get x of 0, which is c1 plus half, or c1 is equal to uh, c1 is equal to this as 1, right? C1 as half. Now x dash minus y is equal to e to the power of t. This is the equation given for us. And this is y is x dash minus et, or y of t will be x dash, which we found this. So this plus minus e to the power of t. Now let us substitute uh, when t is equal to 0. Okay, so y of 0, which is 0 plus c2 plus half minus half, and then minus 1. So these gets cancelled, and y of 0, which is 0. So you will get c2 as 1. Now we got c1 as half and c2 as 1. So we get x and y. So let us substitute it. Now we get x as when we substitute it, c1 and c2, which is half cos t plus sin t plus e to the power of t divided by 2 minus t by 2 cos t, or x of t, uh, if you take half as common out, e to the power of t plus 2 sin t plus 1 minus t cos t. Okay, and y of t will be minus half uh, sin t plus cos t plus half e to the power of t minus half cos t, and then half t sin t minus e to the power of t. Uh, then we get after uh, do this simplification, if you take half outside, so this is cos t as 1 minus t sin t minus e to the power of t. So we got x and y. Now we'll see by Laplace transform, by using Laplace transform. So let us rewrite the question which we had, uh, um, since that is x dash plus y is equal to um, dash minus y is equal to e to the power of t. Right, so hold on. Fine. So now let us apply Laplace transforms for both, right? So this looks like this is Laplace transform of x dash minus a Laplace transform of y, which is equals to Laplace transform of e to the power of t. Okay, and the Laplace transform of y dash plus Laplace transform of x. Okay, and which is equal to Laplace transform of sine t. Okay, so this is s into L of x, okay, minus x of 0 minus L of y is equal to 1 by s minus 1, and this is s into L of y of t minus y of 0 plus L of x is equal to 1 by s square plus 1. Okay, so this is s into we got these two results. Let us substitute it. S into L of x, okay, of x minus 1 minus L of y is equal to 1 by s minus 1, okay, and this is s into L of y minus this is 0, uh, so it will be plus L of x is equal to 1 by s square plus 1. Okay, now we can take this on other side. So s of L of x, okay, minus L of y is equal to 1 by s minus 1 plus 1. Okay, and when you take this and to the numerator and try to simplify it, minus 1 plus 1 gets cancelled, so you get s by s minus 1. Okay, now keep this as equation 1 and equation 2, okay, and multiplying equation 1 by s and equation I mean adding it, so we get as so now we get as s square plus 1 into L of x, which is equal to s square by s minus 1, okay, plus 1 by s square plus 1, and then taking s square plus 1 on the other side, so L of x will be this is s square divided by s minus 1 into s square plus 1, and this is s square plus 1 whole square. Okay, and we need x of t, which is L inverse of this is s square divided by s minus 1 into s square plus 1 plus L inverse of 1 by s square plus 1 whole square. Now let us find uh, uh, for this by using partial fractions. So s square by um, s minus 1 into s square plus 1, which is equal to a by s minus 1 plus bs plus c divided by s square plus 1. So we get a value as 1 by 2, b value as 1 by 2, and also c value as 1 by 2. Now substituting all this, okay, and we get as now let us substitute the value of a, b, and c for this. So L inverse of s square by uh, s minus 1 into s square plus 1, okay, which is half of L inverse of 1 by s minus 1. Okay, since a is 1 by 2 and b is also 1 by 2 and c is also 1 by 2, and we'll split it, plus half of L inverse of this is s by s square plus 1 plus 1 by s square plus 1, okay, which is equal to half of e to the power of t plus half cos t plus sin t. Okay, we got the first result. Now let us find for L inverse of 1 by s square plus 1 whole square. Now this can be split in terms of the functions as L inverse of f of s and g of s. Okay. So by using convolution theorem, we know that L inverse of f of s and g of s is integral 0 to t f of t minus u into g of u into d. Okay. So which is integral 0 to t. So f of t minus u is sine. I mean, uh, please remember this. F of s is 1 by s square plus 1, and g of s is 1 by s square plus 1, and f of t will be um, which is sine t, and g of, okay, and g of t will be also sine t. Okay, so this is sine t minus u, and g of e is sine u, okay, into du. Fine. Now further solving it. So this is integral 0 to t sine u into sine of t minus u into du. This can be written as integral 0 to t. This is half of cos of u minus t minus u, okay, minus cos u plus t minus u. Okay. This is t. So we get this as half of integral 0 to t uh, cos 2u minus t minus cos t. Okay. Then the bracket du. Now this is half. This is cos is sine. So sine of t 2u 2 by 2 minus t into u uh, within the limits 0 to t. So when you simplify it, you get half of sine t minus t cos t. Now let us substitute all this. Okay. So now that we got all the results, let us substitute. We get x of t is equal to half e to the power of t plus half uh, of cos t plus sin t plus half into sin t minus t cos t. Okay, so after simplifying, we get x of t as half of e to the power of t plus 2 sin t plus 1 minus t cos t. So we got the same result which got it over here. I'll show it to you. See. Now to find y of t, um, we can use any of those equation. Let us use x dash minus y is equal to e to the power of t. So your y will be uh, x dash minus 18. So differentiation of this, we get y of t will be half after substituting it cos t minus 1 minus t into sin t minus e to the power of t. Okay. So I hope you enjoyed this session. Right. Please do comment. Okay. Please like, share. Yeah. Thank you.